Well, welcome to the last lesson in this unit or this chapter. And the section that we are on right now, this is the most difficult section in the unit, and it's on solving compound and absolute value inequalities. By the end of this lesson, after you've done some practice, you should be able to solve compound inequalities and also to be able to solve absolute value inequalities. So let's talk a little bit about compound inequalities. Okay, a compound inequality is basically two inequalities that are joined by the word and or or. And to solve a compound inequality, we basically solve two separate inequalities. Okay, we solve each part separately. And hang on, I'm having a little technical difficulties there. Okay, the graph of a compound inequality that has the word and is the intersection of the solution sets. And the graph of a compound inequality that has the word or is the union of the two solution sets. Compound inequalities involving the word and are called conjunctions. If they have the word or, it's called a disjunction. So a little bit of vocabulary there for you as well. So let's look at some examples to solve a compound inequality. So you can see that this one has two inequality signs. So basically what you're going to do is you're going to go ahead and you're going to solve, we're going to solve this one right here without that inequality. Solve that separately, that's this one. And then what you're going to do is you're going to solve this one independently. Okay? So that's the plan of attack here. So separate them out and solve them independently, just like you know how to do. And you end up with the left-hand side, we get x is greater than or equal to 1/2. On the right-hand side, I'm not going to take a lot of time to go through the math because this is pretty straightforward. So we have two solution sets, okay? X is greater than or equal to 1/2 and x is less than 2. So we're going to write that in interval notation, and we're also going to graph it on a number line. So we can write the solution as x is less than 2 and x is greater than or equal to 1/2. Whenever we have a compound inequality with an and, we can write it as a single statement like this with two inequalities, and the variable will always be in the middle. Okay, so I want you to get practice writing those. In interval notation then, 1/2 is smaller, it stays on the left. 2 is bigger, it stays on the right. 1/2 is included, so it's going to have a square bracket. 2 is not included, there's no equal to sign, so that'll be a parenthesis. So that's what it'll look like in interval notation. This endpoint is included because it has the equal to, not included, no equal to. So then on a number line, what you're going to have is you're going to have 1/2 and then positive 2, open dot on 2 because it's a parenthesis, close dot on 1/2 because it's included. So not too bad there for the inequalities. Here's another one. It says solve y minus 2 is greater than -3 or y plus 4 is less than or equal to -3. And then we're going to graph it. So you know how to do the math on this. Add 2 to both sides, subtract 4 from both sides, and we get two solution sets. So in interval notation, now what you're going to look at, -7 is to the left of -1 on a number line, right? So we want all the stuff that's smaller than -7, so that'll go to the left. All the stuff that is bigger than -1, which will go to the right. Okay, so in interval notation, we have two separate intervals from -∞ up to -7. It does include -7, so it's a square bracket. And then we have another interval starting at -1 and going to the right. On a number line, it looks like this. So you have your first interval goes from -∞ to -7. Second interval goes from -1 to +∞. You don't have to graph these separately. I would like you to graph it like this third one. The third one is the solution to both of those. So one of the things that you will notice when you have an or statement, most often you're going to have two different sets of inequalities of intervals, two separate inequalities, and two separate graphs going opposite directions. And when you have the one that has an and, that's a compound inequality with and, they will go towards each other and just have endpoints on the end. So here's where we get a little bit more complicated. Absolute value inequalities can be solved by rewriting it as a compound inequality. If the absolute value is less than or equal to, then it's an AND statement or conjunction. I would just encourage you to write the word AND, okay? If it is an absolute value where you have a greater than or equal to, then it's a union or a disjunction, and this is the word OR, okay? So let's go ahead and take a look at some examples. Here's some rules for us. For all real numbers, A and B is greater than 0, the following statements are true. Okay, it says if we have the absolute value of A is less than B, then what's true is A is less than B and A is greater than negative B, or the opposite of B. This is super, super, super important. So go ahead and highlight this. Make this stand out in some way. This is your rule. This is how you're going to solve these. Okay. The second one, if A is greater than B, then you have an OR statement. Okay. So if you have a greater than, then you're going to get this statement. Notice this is an AND, this is an OR. Here are your specific examples. For example, if you have this one, then you're going to get 2x plus 1 is less than 5 and it's greater than negative 5. Down here, if we have 2x plus 1 greater than 5, then 2x plus 1 greater than 5 or 2x plus 1 less than the opposite of 5. Okay, so that's how you're going to set them up to solve them. So this one says solve the absolute value of A is less than 4, graph it on a number line. What this means is the letter A, or whatever A is, we want all the stuff. It says it's the distance between A and 0 on a number line less than 4 units. Okay, so here's what it's going to look like. We want anything that's less than 4 units. So it's all the stuff from 0 up to negative 4 and from 0 up to positive 4, but it does not include the endpoints because there's not an equal to. So our solution is all the numbers less than 4 and greater than negative 4. Those are all the solutions. In interval notation, you would have a parenthesis, negative 4, comma 4, and a parenthesis. Okay. So example 2 down here at the bottom, it says solve the absolute value is greater than 4 and graph it on a number line. So this is very similar to the one above, but this time we have greater than, which is an OR statement, right? It means the distance is greater than 4 units. So we're going to start at negative 4 and go outward, start at positive 4 and go outward. We want a distance bigger than 4. So our solution is A is greater than 4 or A is less than negative 4. Using what I highlighted from that last slide, right? Here's one where it says solve the absolute value of 3x minus 12 greater than or equal to 6. Remember, greater than is an OR statement, and we're going to graph the solution. So here are your two statements. The first one, you can just drop the absolute value. Okay, so it's 3x minus 12 greater than or equal to 6. Or we're going to get 3x minus 12 is, and you flip it, less than or equal to the opposite. Solve each of those independently, okay, like you know how to do. And we get x is greater than or equal to 6 or x is less than or equal to 2. So 2 is smaller, it's on the left. So interval notation, 2 will have a square bracket, 6 is going to have a square bracket, but we're going to have two different intervals, right? Because it's an OR. So we're going to have from negative infinity up to 2, it includes 2, from 6 to positive infinity, and it includes 6, and it's the union of those two intervals. Here's our graph, all the numbers up to and including 2, all the numbers after and including 6. That's it for this video. These are confusing. Please take your time and we'll practice these in class. See you next time.